Hello ladies and gentlemen, it's time to dive into the shocking world of electricity. Today's topic is the current divider rule, which is essential for analyzing current through parallel circuits. But first, let's introduce you to my co-host, Skippy the Bush Kangaroo, who's going to help us learn this topic. Good idea, Skip. Let's start with the basics. So what is current? Well, it is simply the rate of flow of electric charges through a specified point in a circuit. By convention, we analyze current based on direction that a positive charge carrier would flow, which is from the positive terminal to the negative terminal of the source. But what happens if the current approaches a junction in a parallel circuit with resistors? Well, we know that the total current that flows into a junction must flow out of a junction, because electrical charge is conserved. But how will it split across the branches? Well, it will split in inverse proportion to the resistance of each parallel branch. Yes, it is a bit confusing, Skip. Well, let's imagine water flowing through a river that has to split down 3 branches. In this case, the water represents the electrical current, and the branches represent the parallel branches of a circuit. If we make branch C narrower by building walls in the branch, then far less water will be able to flow through it. Increasing the resistance of a branch of a circuit with a resistor will produce a similar effect. Hence, the lower the resistance of a branch, the greater the current. As you can see in the circuit simulation, we have current flowing through 2 parallel branches with different resistances. 0.5 amps flow through the 20 ohm branch, but a total of 2 amps flow through the 5 ohm branch, which is 4 times the other branch. This is because it only possesses a quarter of the resistance. Yes, Skip. Let's do some math. The general formula for the current divider rule is Ix is equal to RT over Rx multiplied by IT, where Ix is the current flowing through a specified branch, IT is the total current flowing into a junction, Rx is the resistance of the specified branch, RT is the total resistance of the parallel network. Now let's do an example of the current divider rule. Here we have a total current of 10 amps that must flow through 3 parallel branches, each with different resistance values. Our first step is to calculate the total resistance of the parallel network using the following formula. Now we enter our resistance values and rearrange to obtain the following result, which gives us a total of 80 ohms. Now that we have all our values, we can use the current divider rule to calculate the current in each branch. We obtain I1 is equal to 8 amps, I2 is equal to 1.6 amps, and I3 is equal to 0.4 amps. Do our results make sense? Yes. As you can see, the most current flows through branch 1, which has the lowest resistance, thus demonstrating an inverse relationship. But only 0.4 amps flow through branch 3. Well, that's it from me and Skippy for today. I hope you enjoy learning about the current divider rule, authorized by the Australian Government Canberra, and I'm speaking really fast because I'm running out of time.